Hello and welcome to this Biotech Connect webcast. This is episode 8. Today we're gonna start with the 3-minute thesis from James Pemberton, who's from University of Toronto and he's doing his PhD. Then we will talk with my new guest, which is a returning guest, Alex Rochette from New England Biolab. Thank you so much, Alex, for coming back and accepting to give your comments on James' thesis. And then we will have a chat with Alex about the new reality in the labs, in the science in general. So stay tuned for this episode 8. Thank you. First thing first, we will start with James Pemberton 3-minute thesis, which is about understanding the mechanism of puma-induced neuron death.
My grandmother has Parkinson's disease, a disease that has stripped away her ability to walk or even move. Neurodegenerative conditions like Parkinson's or Alzheimer's, they affect the lives of nearly 400,000 adult Canadians and are diseases directly caused by the inappropriate death of the cells in your brain. But what if I told you that the death of your brain cells, which are called neurons, isn't always a bad thing? On the contrary, did you know that nearly half of the neurons in your brain dies naturally in development? What I mean by naturally is that this death is no accident. Instead, it's a controlled event executed by tiny proteins. And being a 3-minute thesis competition amongst Canadian universities, I thought I'd use a hockey analogy to explain. Imagine within every neuron there exists a microscopic game of hockey, with the winner of this hockey match determining the fate of that neuron. Some proteins are playing on team survival, while others are playing on team death. Now during development, both teams are evenly matched, which is why team death wins nearly half the time. But don't worry, the neurons that die during development are ones that didn't form those proper connections. After growing up though, neurons are extremely hard to replace, so keeping them alive is vitally important. As such, this hockey match changes, favoring team survival to win nearly every match and every neuron in the adult for the rest of their life. However, for reasons unknown, in some individuals like my grandmother, team death starts to win its hockey matches, resulting in the symptoms and pathology of terrible neurodegenerative disease. This is where I'd like to introduce you to my thesis. In order to stop neurodegenerative disease, we need to prevent neurons from dying. And to prevent neurons from dying, we need to understand how this microscopic game of hockey works. My contribution to this field has been the study of one protein in particular, called PUMA. What I found so far is that PUMA kills young neurons, but not adult ones. And this was a strange finding because previous research has shown PUMA contributes to Parkinson's disease, a disease that affects the older adult and older neurons. So how can this be? If PUMA can't even kill an adult neuron, how can it contribute to this disease? Well, this led to a really exciting idea. What if neurons in development share similarities with neurons in disease, which would then enable PUMA to kill? Allow me to explain more. We know that in both development and disease, this hockey match determines the fate of a neuron. And we know that in both development and disease, team death wins its hockey matches, with PUMA playing at center ice. Therefore, I think if we can understand why team death wins in development, this will give us insight to why team death wins in neurodegenerative disease. That's why I'm trying to figure out not only how this game of life works, but also the changes that occur to it during development, as these changes may be the same that occur in disease. Overall, the idea is to one day be able to prevent neurons from dying, and hopefully end neurodegenerative disease altogether. Thank you.
And we are with Alex Rochette again. Thank you for coming back for our second episode with me.
You're very welcome. It's fun to get out of the routine.
Yeah, exactly. And, a really different routine than we used to do. But still, after 3 months of this pandemic, we can say this is the new routine.
Mm-hmm. Oh, it is. It's quite different from the last episode we did, which was what, in March?
I think it was among the first one, and indeed it was in March. Everything was new. I was all by myself in my basement doing those capsule, and in between I got a job. We can come back about this. I would like first to talk about the thesis from James Pemberton from Toronto University. We just listened to him. It was about a protein involved in Alzheimer's disease. Do you have any thought about this, his work?
Yeah, I mean, so the work in general, super interesting. Definitely, it's of the topic. There's more and more people aging, so there's big interest in neurodegenerative diseases, and most of the drugs involved in trying to treat Alzheimer's failed, and so that's why it's so important to study this in academia.
I could, really understand James' idea of choosing this project based on his grandmother. My grandmother too was affected by this terrible disease.
Yeah, it's so many people, and so many people that we know are probably going to be affected because we're only going to find out in how many years. So yeah, it can get very personal for a lot of people.
And he was right about this Canadian wide thesis contest to use a hockey metaphor. That was great. That was well played.
Oh, if I can actually say like two things, so quick question: was he starting or finishing his PhD?
Oh, I don't know. I don't have this information.
The presentation skills were clear, concise, and really good. So if he's only starting his PhD, I'm very eager to see, his future seminars. And plus, the cockiness to actually take the time to say in a 3-minute thesis that it's only 3 minutes and finish 4 seconds in advance. Yeah, so I noticed.
Yeah, that's it. He's natural with speaking, and this is really important because in science we're looking for people not only able to understand, to do it right, but to explain it right.
As a professionally trained scientist, it will always be a responsibility to communicate to the lay people, like what is science, how to better understand.
Sure, exactly. There's only few people, on TV that are able to explain it well.
Definitely.
So thank you very much, James. Sorry, we got just only few episodes from for a couple of weeks. So he sent us his thesis about a month ago, but as I will explain in a couple of minutes, I got a new job, and so I'm doing those webcasts only part-time now, but I feel that it was important to present all the thesis that was submitted during this 3-minute thesis contest. So good luck, James, and thank you very much for submitting your 3-minute thesis. So back with Alexandre Rochette. Thank you very much again. As I said earlier, it's a little bit more difficult for me right now because I got a full-time job other than Biotech Connect. As you know, I cannot work, I cannot do my event.
Yeah, tell me, what's more important than talking science in the webcast? What are you doing?
I got something for you. I got the right answer. So basically, I got this nice opportunity to work actually on the SARS-CoV-2. I'm doing serological assay. So basically, I'm doing ELISA on real serum for patient. So basically, I'm back in a lab in one of the Montreal team working on this. And I got recruited because they needed someone lab ready to go and to start immediately.
How do you like it?
Yeah.
And you've been out of the lab for how long now?
I'm in the lab for about 5 weeks now. So basically, I started mid-May, and at the time of this recording, we are, June 20. So basically, a little bit more than a month. To be honest with you, Alex, you knew me as our starting Biotech Connect. You were among our first clients. So basically, it's been 5 years. So obviously, 5 years without touching any pipettes.
Hmm.
And before that, I was working for Medimabs. The 2 last years I was working with Medimabs, I was mostly doing the marketing, the sales, so not much of labs either. So we can say safely that I was not working in a lab for 7 years.
And how's the pipetting skills going?
It's good, actually. It took me around 2-3 days to be back, top shape. I did a couple of ELISA, and I was pretty proud of my how do you say that in English? Écart type was
Oh
pretty
yeah,
good.
your standard deviation was
Standard
pretty.
deviation. At first, my first, I must confess, my first ELISA standard deviation was kind of, oh, what you did there, But it's not like I was learning it, from scratch. But to be honest with you, I could not assume that it would be like, riding a bike. Once you do, you can do it all your life, even if you stop for a long time. I was not sure it was the same, but finally, it's not so different.
Yeah. I mean, the muscle memory is there. It's just about remembering how to set it up and trusting your hands. And also, we did age a bit. And so are we still as steady as before? Or can we drink as much coffee as back in the day and then pipette? Maybe not.
And about you, Alex, what have you been up to during those 5 last week where I could not, do actively my contact with you?
It's true. So let's say like at the start of the pandemic, it was mayhem to deal with the increased demands for all the regions for COVID testing and research. So just as a reminder, as New England Biolabs, we offer enzymes. And so these will be used in labs for diagnostics and research for sequencing. And that was a worldwide demand. And so as the Canadian office, we had to do proper forecasting and project management to request just enough enzyme for the research needed for, let's say, 2 weeks, and then work really as the lots were coming in. But NEB was amazing in terms of refocusing their production. And so we never said no to someone. We just managed to fulfill the orders and make sure everything kept going. Now, the 5 last weeks, that craziness started slowing down because it was now part of the new normal. So we knew.
I suppose at first it was all emergency.
It was all, yeah, at first it was all last minute. We needed last week. Even the labs and the hospitals didn't really know what was going to happen next week. So they had an idea of forecast. But now, yeah, it's now everything's part of the normal. We had, we knew what to expect, when to expect, to whom. There's also big sequencing projects that came on. And so that was interesting. But now the new, not worrying, but very interesting thing is that Quebec is opening their labs a lot faster than the rest of the country, and all at once.
So you're getting, orders from normal labs. I mean, labs not working on SARS-CoV-2.
No, exactly. And so back in the 3 months ago, where all the orders went down, but the new urgent orders came up, they still exist, but now everything's coming back at once. So we're now getting a lot of new orders, a lot of more deliveries to manage, to be sure it gets to the right place. Like, I love this type of research going on. And, Quebec and Canada has so many great labs that there's no reason for all of this happening. And I'm also extremely interested in this new normal coming back to the labs, where we have so much expertise to do tests. Like, your lab is making an official ELISA test to look at antibodies. And so I feel like every lab should be, or every university should be able to make just a quick COVID assay to screen the students and the staff. It doesn't have to be the official one, but it's a really good first line of, let's see if someone's infected or not, and then go to hospital.
Yeah, to internally test their people. Yeah.
Instead of having, I was gonna say, instead of having to wait until like an official kit is released and then pay extra for a private kit, labs have expertise to make something up. Of course, they need the right controls and validation, but let's see what happens. Let's see if how smart our students are.
Yeah, and in fact, this is real easy. ELISA are among the basic sorry about that, basic protocols that we can do in a lab. So I feel that about every lab is able to do it. The only thing is to get the proper proteins, the proper regions. And I'm really proud to say that in our lab, we are autosufficient. So we have the construct, we are doing the maxi prep, we are transfecting the cells, and we are producing ourselves all the proteins that we need.
There's, if ever you need an outside control just to revalidate your lots, there are some recombinant spike and RBG proteins on the market.
Sure. In fact, probably that we started from a commercial one.
But I will say there's a lot of labs out there that they love to make their own Taq polymerase. Students have that as a lab job. Oh my God, is that a dirty polymerase, the way they make it?
Yeah, but it's not the same. We are working with proteins that we are using simply to test if they bind to the antibody or not. This is one step easier, of course. And we have a nice construction from different, because all the teams working on this wants to collaborate with us. Of course, each lab wants to publish, but other than that, when we have our story published, we share the reagent, and we are sending a lot of RBD, the domain from the spike. We are sending to a lot of labs. I think we are providing all EMA Quebec with it, because they are using our ELISA test for other cohort. So basically, everybody worked on it.
It's amazing. And plus, it's great that you make those proteins for EMA Quebec and others, because there was a big talk about the availability of reagents for testing. Obviously, they meant more about, let's say, RNA purification or the swabs. But for local labs to be able to produce them for others means we're not dependent on outside sources that, might not be able to fulfill orders for everyone. So great for everyone.
That's fun to be part of it.
It's great. I mean, on our end, we're NEB's building protocols for fast colorimetric detection of SARS-CoV-2, which means it's a swab directly in the master mix, wait 30 minutes at one temperature, and it changes color if it's positive.
So basically, let's explain it in more detail, for people that are not working in that specific field.
So let's say we talk about just PCR. You have DNA, RNA, 2 primers, and then you do cycles of amplification where it just exponentially amplifies the target. LAMP is a mix and match of 4 to 6 different primers, and the enzyme used has some de-annealing properties. And so the primers will then bind to the target, as well as potentially themselves creating loops. Your polymerase will work at only one temperature, amplify, de-anneal the primers, which will then anneal somewhere else, and it will just create a big zigzag, which is going to make a big mesh of DNA or RNA in that, DNA still, but that has an RT property. The goal is that that can get super specific because of the amount of primers needed, and you can get really sensitive. It goes to very few copy numbers. And so it's great when you just do, let's say, saliva or a nasopharyngeal swab, wait a bit, put it in the medium, in the master mix, and then you just put it on a water bath and you wait for a color change, and you do not need a plate reader nor fluorescence. So it's great for point of care. It's great for labs that are far away in remote regions that don't have access to the machines. It's great for cost overall. But you don't need to wait for RNA extraction reagents either, which was in high demand for, let's say, the Magisi or anyways, other automation devices. And that's super cool. And so, but it's hard to optimize. It sounds simple. You can do it, but to get sensitive enough, it needs a lot of work. And so there's some enzyme work, some primer work, some buffer optimization work, some additional reagents to modulate the enzyme activity. But luckily enough, we've been working as NEB with Massachusetts General Hospital, who deal with the clinical samples and us with the reagents. And those protocols are continually published, free access. We don't want to just keep it for ourselves. We need that protocol out there for people.
This is, the principle of open source that we see more and more in informatics, and this is great. This is really interesting to have something that easy to understand as a color change.
No, seriously, as opposed to, let's say, like, there was a big news release about the company Abbott who made ID Now. It's like, oh, it's a 15-minute test for SARS-CoV-2, but you need to buy the machine, buy the cartridge, put the swab in, and it's one assay per 15 minutes. Kind of ridiculous. as opposed to, let's say, doing the lamp colorimetric in a 96-well plate, or like not 96-well plate, let's say just like strips of tubes, but just do it a bunch at a time, put in an incubator, and then wait. So yeah.
Yeah, because 96 well plate will be too small to do the.
I don't know if it's too small. It's just that then you need an actual plate, some multi-channel pipettes, and the swab doesn't get into it, and so it's a bit.
Maybe those a little bit bigger wells. Those anyway.
Yeah, but still, I mean, research is fun. So I'm really happy you're back in the lab to help with the effort.
And this is good for me to go outside of the house to have something really precise to do. And I realized after a couple of weeks that I was kind of anxious being home every time, every day, not knowing when Biotech Connect activities will be able to resume. So that was good for me. So I'm really happy, and I'm glad that of course you included. All my friends are proud and happy with for me about that, and I'm really lucky. I got interviewed for the radio, the national scientific show, Les Années-Lumière, Radio-Canada. So I'm really proud of it. And most of all, I'm really happy that you accepted on the weekend. Let me tell you that Alex was kind enough to come back with me on Zoom, of course, but during the weekend.
So fine. I made some time. So
thank you so much. And
it's not as if like I have a lot of places to be, but it's my pleasure to be with you. I miss you, man.
Yeah, of course. And as you noticed, since the beginning of my job, we have less time to play those board games online that we used to do a lot when I was home all day long. So maybe we can give a shot to it, later today, if you want.
Oh, so, let's find some time.
Thank you so much, Alex, for this, and a nice new look with the the little hair that you got growing on you.
So the pandemic is there to try new stuff. So let's see if I shave that at some point.
Facial hair, like they say in English, that this is not an expression we are used to in French.
Des cheveux de face? Non.
Des cheveux de face, non. Donc, merci beaucoup, Alex. Puis, tu peux retourner à ton week-end. Merci beaucoup. Profite de la belle journée.
Ciao.
Thank you. Bye-bye. Thank you, everybody.